right, we should be right on the back of the page that we were on yesterday. And we saw this show up in our problems yesterday, but we didn't like talk really exclusively about it. I'm going to scroll back up for just a second. On this problem here, letter B. What, if you guys remember, what did we say those two circles were telling us? They're the same, okay? If you know that you have two angles that are the same in the picture, does anyone out there know anything else that could be said about that triangle then? What are you saying, Parker? It's isosceles. If you have two angles that are the same, that means then in the picture that there would be two sides that are the same as well. And they're actually the sides that are across from those congruent angles. So in this case, the side across from that angle and the side across from that angle would also be congruent to each other. Now, we didn't talk about that yesterday because I knew it was going to come up today. And you guys probably, maybe some of you know what that word isosceles means because you've maybe talked about it before you got to geometry. So we're going to focus a little bit more today on just isosceles triangles and a little bit with how do we use what we know about their sides and their angles to help us solve for something that might be missing in the picture. Okay, so I'm going to come down here. If you remember yesterday, we talked a little bit about how we'll sometimes have to still prove things in class. And so we're going to talk about an isosceles triangle, but we're going to prove why an isosceles triangle does this. So up above here it says prove that the base angles of an isosceles triangle are equal using triangle congruence. Triangle congruence still means side, 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 angle, like those tests that we've been working with before we kind of switched gears into properties of triangles. So I'm going to try to prove that this is an isosceles triangle, and then that means that these base angles down here, A and C, would be congruent to each other. Before we jump into that, I just want to focus on isosceles for just a little bit, because you guys already were able to tell me that isosceles means two sides are congruent. Two sides are the same. That also means two angles would be the same. And they're calling them the base angles, but I want to make sure you guys understand what they mean when they say base angles, like where would they be at in the picture. So I'm going to draw a picture up here in the corner of just a real basic isosceles triangle. Okay, that would be just a simple isosceles triangle. I know that two sides are the same. This third side down here then would be different. Maybe when you learned about isosceles, your teacher maybe said, think about the word isolate. Two are the same, one's different, so you're isolating the different side. That's where they kind of maybe made that connection between isosceles. Now, there's something called base angles, and I kind of talked about this on that example I scrolled back up to. But the base angles would be directly across from those congruent sides. So if I called this triangle JKL, where would the base angles be? Where are the angles directly across from the congruent sides? L and K. So these would be your base angles here. And that would tell you that they would be equal to each other. It's important that you can recognize where the base angles are because they might switch the perspective of the isosceles triangle. Okay, what I mean is maybe they'll go like this instead. And they'll say that these two sides are the same. Let's say we call this triangle M, N, and O. Where would your base angles be now? O and what? M? Yeah, because those would be across from those congruent sides, okay? Understand that anytime you see congruent sides on a triangle, those angles that are directly across from them are going to be congruent as well. In an isosceles triangle, we call those your base angles, okay? So now let's get into our proof, because we want to prove that those base angles are always going to be congruent anytime you see an isosceles triangle, because then going forward, when I start to do problems with isosceles triangles, I know this information and I can use it to help me solve. So they kind of got it started for us. So let's just look at what they wrote down here. For step 1, we have that this is a triangle ABC, and we're told that it's isosceles. They also did a construction, kind of like what we did yesterday with that proof. We had that construction of that parallel line yesterday. This time they're constructing a bisector of the side AC. AC is the bottom of the triangle here, and this dotted line in the picture is our bisector. Again, you guys have already learned how to do those kind of constructions. We've constructed perpendicular bisectors before, or even just regular bisectors. We've done all that. They're doing the construction for you, and they're just showing that with that dotted line. Okay, we want to prove that angle A is congruent to angle C. If you think back to when we did our proofs at the beginning of the unit, anytime we're trying to prove that like angles or sides are equal to each other, we have to show that triangles are congruent first. So I want to get to one of my congruence tests to begin with. So let's go into our given a little bit more specifically here, because they told us this stuff, but they didn't mark anything on the picture. So we just talked about isosceles, and that means that two sides would be the same. So if you look at that triangle, what two sides do you think would be the same? Name them. AB and CB. So let's write that out. AB would be congruent to CB because we're using the definition of isosceles. And I'm going to give those 2 dashes. That's the first piece from our given. Now they're also telling me in my given that BD is a bisector of AC. What does that word bisect mean? We've talked about that before. Splits it in half. So that line that's being drawn in is splitting that side AC in half. So what segments on the bottom would be the same? Good. AD and CD should not be the same. So I'm going to write that down next. And this is using definition of bisector. Okay, and then I'm going to go ahead and mark those sides. I'm going to give each of those just a single dash. Okay, I've used everything from my given. I talked about what it meant for it to be isosceles, and I talked about that line that's being a bisector. I'm not quite ready to say that these triangles are congruent yet because I don't have 3 things marked. I only have 2. Is there something else though in the picture you guys think we could add? Well, I don't that's what we're trying to prove is A and C. What do you guys see? Macy? Because of? Good. Good, that side in the middle, it's shared. We've seen that show up a lot in these kind of proofs. So we should be able to mark that and say that those would be congruent as well. Okay, so now those 2 smaller triangles in the picture, kind of the line that cut the big triangle in half, can we say that those 2 smaller triangles are congruent now? What test allows us to say that? SSS. So that's going to be my reason, side, side, side. But I need a statement over here. I need a triangle congruent statement. Keegan? Very good. Make sure we're keeping those letters together that we know should kind of correspond. It's important that we do that. All right, we're not quite finished. We got to our congruent triangles. And this is something that we talked about last week. If you have congruent triangles, that means that everything about them should match. So I should be able to say that those base angles A and C are congruent. Do you guys remember what the reason was? Good, CPCTC. Remember, that means corresponding parts of congruent triangles are congruent. So these matching pieces that aren't marked, because they're on congruent triangles, we can assume that they would be congruent to each other. So A and C, for example, should be congruent. Those are also known as those base angles of the big triangle ABC, because that was the original triangle we started with that we knew it was isosceles. All right, Now, this is not a proof that you guys need to be working on memorizing, unlike the one that we did yesterday. The one we did yesterday, if you guys remember, I warned you is going to show up on your test and on your review. So you're going to want to make sure that you're going back to the notes from yesterday and remembering all those steps and reasons. Now, this one, I'm not going to be testing you on, but it's just important that we understand why can we do this with isosceles triangles. Okay? What we're going to do now, though, is come down here and we're going to solve some problems. So letter A wants us to figure out what the measure of angle C would be. I would suggest on any of these problems with isosceles, like markings, to maybe mark your base angles first. So if you guys look at this triangle ABC, where would the base angles be? B and C. So I'm just going to put an arc on both of those, just as kind of a reminder to myself. This is an isosceles triangle because these sides are marked with a dash. And so those base angles, those angles across from those sides have to be congruent. Okay. How would I go about solving this then? Greer?
180 minus 98 equals 2x.
Equals 2x, you said?
Yeah.
Where'd you get x's from?
It's the same angle. B and C equal the same, so they're x.
Okay, you don't know what they are, so you gave them a variable. Yeah? That's great. And we know that they're the same, so we can call them both x. And we're taking 180 minus 98 because we know that those three should add up to 180. And so you got to subtract away the 98. What is 180 minus 98?
82.
82. So we have 82 equals 2x. And then what? 41? So angle C should be 41 degrees. Okay. Is there another way we could have solved that? Keegan, what'd you do? So 180 minus 98 and then just divide it by 2. That would work too. You still get 41 there. Okay. I don't hate the x's in there just because for some of you, especially when we were doing these problems yesterday, I'm just going to scroll back up, like this one here where there was a lot of x's involved. If you don't know what an angle is and you have like a lot of expressions being given to you, you can just call anything that you don't know x. And then you can use that variable to help you set up an equation. So that's also an okay way to like approach this. And I know for some students that actually makes more sense to call what they don't know a variable, because then they can set up an equation and solve it because they feel really comfortable with being able to do that. But that was two different ways to solve it, like to solve that same problem. You both get 41 degrees, whether you used x's or you didn't. All right, let's come over here to letter B. I want to find the measure of angle A. First thing I'm going to ask you guys is where are the base angles?
BC.
B and C. And how do we know that those are the base angles?
Because they're across from each other.
Yeah, these sides are congruent. So directly across from those sides are your base angles. Good. So you know B is 65. So what else do we know then? C is also 65. Because those are your base angles, so they have to be the same. So how would we find A? Subtract from what? And you get 50. Okay, really quick before we move on from this one, here's what I've seen some students do. Is that wrong? Yeah? And that's not going to get you 50. What are they doing wrong here? Logan? One of the base angles. Yeah, some students will look at a picture like this and they'll assume, oh, you gave me that angle, so that must be the one that's like on the top of the isosceles triangle that's different than the other one, so those other two that I'm missing have to be the same. Some students make that assumption. That would be incorrect. That's why I said it's maybe important or helpful to mark your base angles first, because I don't want to see any of you make a mistake like that. Okay, but it happens because if you're rushing through something or you're not paying attention, you're going to get the wrong answer. All right, let's go to the last one here. This one's going to require some thinking, guys. How many isosceles triangles are in this picture? 2. Okay, so let's start with the first one, ABC, because that's the only thing that actually has a number. What are your base angles on the triangle ABC? C and B? Okay, so how could we maybe solve for those angles? Yeah. And what does that come out to be? 70. Nope. Close. 72. So these are both 72 degrees. Okay, now what would we do? Greer?
You would subtract 72 from 180 and put it on the other side of angle C.
Okay, because this angle C is kind of split between the two triangles. Those side-by-side angles make a what? A linear pair. So if we take 180 minus 72, how much is that? 108, and that would be that corner. Good. Now we're on to the next triangle here. Where are the base angles at on that triangle ACD? Good, A and D. So I'm going to mark these with 2 arcs instead of just 1. And I want to finish this off here. So I want to solve for these angles. I only need to know what D is, but we know that A and D are the same. So what would you guys do? And you got 72 from doing what? And what do you get? 36? Good. Questions on working with isosceles triangles? Okay, I have a worksheet for you guys, so I'm going to get that passed out.